Hey, good evening, guys. This is Mark here at JTech, and this evening we're going to discuss differentials. We're going to try to take you through a logical power flow through a differential and what some of the major components are of a differential, as well as the total rear end in itself. What many people don't realize is that differential is used in several different capacities when it comes to rear ends in a car. A lot of people refer to a rear end as a differential, but in reality, the differential is actually this part, is the chunk inside the rear end. It has spider gears in which actually do the differential action. Everything else is under what they call the total rear end, or the final drive unit, which is the rear end. So this evening we're just going to take you through a small breakdown of a rear end, as well as with the differential, and kind of explain to you what some of these different options or parts are in the rear end. First off, let me start by saying this is a Ford 2004 F-250 full floating open differential. What I mean by open is it is not a limited slip fossil track rear end. It's just a open differential, so only one wheel will spin. And that wheel that will spin is normally the one that is on the loosest ground, if you will. If they're both on pavement, then they'll both turn equally. But I say if one is off on the grass, then of course that one will spin, and the other one's on pavement or not. All right, first thing I'm going to do is I'm going to remove an axle for you. We have to remove both axles, by the way, in order to get access to our chunk. And it won't take long to take these things out. We broke the bolts loose, and we're just taking this thing to pull them apart, simulating what you'll have to do. One of the things you'll find when you're doing this is there will be fluid laying up here in the ends of the axle tube in these full floaters, because the liquid cools comes all the way through and supplies cooling as well as lubricant to the end bearings. These end bearings are like the ends that you would have on the front end of your car. They are a typical spindle type environment, and they're held on by a nut, and they got two conical bearings that actually crush together. The same thing you'd have on the front end of your car. Okay, so the first thing we're going to do, this axle is already loose, so I'm going to pull it out just a little bit so I can get access to my differential. And then this one here, I'll take it out. And this one is a typical axle in a 1-ton full floating rear end. You can see the splined ends here, as well as your flange. One thing for you all to keep in mind is on a full floating rear end, the axle itself does nothing more than drive the vehicle. It does not carry load, it just carries torque, is what it does. The actual spindles on the differential are what are on the rear end are what carry the load of the vehicle. So all that these axles have are the torque related to them by the drive shaft. Okay. One thing I want to point out to you guys before I take this chunk out, number one, they are quite heavy. I'm going to show you a little bit of power flow through this rear end. Okay, we have, on this end, we have what we call our pinion, and this is a flange yoke that the U-joint will actually fit in. And this is fastened with a large nut to the pinion, which the pinion is the drive gear that runs against the ring gear inside this differential. Okay, and it's lodged farther down below in here, but underneath the chunk, as we call it. Okay, and the drive or torque comes through the pinion, turns the ring gear. The ring gear in turn spins the chunk, and the chunk sends power out to the axles, and the axles send power to the wheels. It's pretty simple, pretty straightforward, if you want to call it that. Okay, now what I'm going to do is take my chunk loose. So again, we've already broke these bolts loose. And one thing you want to be mindful of on these chunks is when you do take these saddles loose or do take the bearing caps loose, you need to keep them oriented to the side they were on in the direction they were on, because these are actually a line honed from the factory, and if you put them in wrong, backwards, or whatever the case may be, or swap from side to side, you can actually cause a binding action in the bearing, which puts an artificial load on the bearings and will burn them out quite promptly. Now the chunk on these are shimmed with thick shims, thin shims, whatever it takes to get the backlash just right, and in order for it to engage properly with the pinion. And now I'm going to take this out and bring it over to the bench and show it to you. The biggest thing you want to do is to make sure that you do not lose or mix up the shims or the bearing caps with the others, because they are mated after they've been run in. They are mated. So we're going to take this, we're going to set it here like this for right now. All right. All right, this obviously is the race for one of the bearings, and this would be one of the thicker shims that you'll use. Ford's real good about using these, and they're real good about cutting them just the right thickness for their backlash on their ring gears. All right, I'm going to spin the computer here for a second. All right, now here is your ring gear, okay? The ring gear is held on by a host of bolts in the back. These are one-time use bolts. Once you've used them, you've torqued them down, and you've set a ring gear and used them, they're a throwaway item after that. You have to replace them. Okay, in case you're wondering, this wheel here with all the teeth on it, this is your tone wheel, and this is for actual speed sensor. Could be for anti-lock brakes as well, but this sends out a analog signal to your computer and tells the computer basically how fast you're going, or if the wheels are turning at a relative speed. All right, now I'm going to spin it around. You can look at the front of the ring gear. Okay, the ring gear is broke down in three sections. You have the heel, which is the top part of the tooth, or the very end of the tooth. You have the flank, which is the center of the tooth, and then you have the undercut, which is the inside of the tooth. Basically three sections coming up, and that's how you set your pattern when you set a pattern up for running your ring gear. You always want to make sure that your ring gear runs on the flank of the gear, okay? Now, also, we have a bolt right here that you can see. This bolt actually pins these gears in place, and these would be your spiders. All right, these are your spider gears. If you can see them, I'm turning them. All right, all four of those make a junction. The two side gears, this one here and this one here, are the ones that drive your axle. All right, and they're the ones that actually take all the torque from the ring gear and push it to either side, or both sides as it would be. Your spider gears are actually what allow your vehicle to turn a corner and your tires to track like they should. Say you turn a corner to the right, your left side tire is going to turn faster, excuse me, is going to turn farther and faster than the inside tire, because it's turning less of a radius, correct? And it'll be the same thing the other way around. All right. In order to tell the ratio of a given gear set, on the ring gear, they're actually stamped. And it could be anywhere from 3.73 to 1, whatever the case may be, which means basically the pinion gear has to spin 3 times as fast as the ring gear, or 3.73 times farther than the ring gear for 3.73 around for one gear, or one turn around on the ring gear. Okay, other than that, the rest of this is just your basic carrier. All right, that everything bolts to. When you're setting up a differential, you want to make sure that you're on the back side of your ring gear. You want to make sure that it's flat. You take a flat straight edge with a feeler gauge and make sure that it's flat all the way through, and you do the same thing with your with your carrier, making sure it's flat. If neither one of them are flat, you're going to have a runout problem, which will give you a lot of headaches when it goes to setting up your backlash as well as your pinion depth and what have you to make sure everything gets where it needs to be. Okay, I've kind of explained, I've went a little bit farther than what I intended, but what I'm going to get ready to do now is put this baby back in its carrier, and we're going to set it down. Oh, and one last thing, this bolt that I had up here, this bolt, if I take it out, this pin here will come loose. You can pull it out, and then you can remove these side gears in the event one of them would have to be bad, broke, or need to be changed out. So just wanted to give you a heads up on that. Okay, now we are going to go back over the differential with a half flat bearing race. Just kidding. Thank you, my helper. So what we're going to do now is we're going to set this back in here the way it's supposed to be. You wouldn't normally just be propping this thing up. You would be very careful putting it in. The one thing you want to make sure you do is when you put it in, you want to make sure you have all your shims as best where you want them as best you can, because once you set it in there, it's in there. Okay, it's difficult to turn around and put more shims in with the differential in. Most of the time, you're going to have to take that differential in and out, in and out. And you'll know more about that as you start setting up your backlash. If you can hear that, that's the backlash you're looking for, but you have a certain amount that you're only allowed. So when you shim it on the right side, it'll push that ring gear to the left, which tightens up your backlash. You shim it the other way, it loosens it. But the one thing you've got to be mindful of, what you take out on the left side has to go in on the right, and vice versa, in order to keep that spacing correct once you get the amount of shims you think you need. All right, that being said, I'm going to turn around now. I'm going to put these caps back on the bearings. I'm going to lightly snug this up and get ready for the next go around. And also remember, when you're doing these, when you're setting up gears in the differential, you're always going to torque those caps down to their operating spec. You don't just run them down a little bit and then check your clearance, because they have to be just right, because the housing will develop some distortion from those caps if you're not, and if you don't have them tight enough, it will throw off your measurements. Okay, my next axle came in. There we go. All right, short of putting the bolts back in the axles, that's pretty much it. Once you get this done, you'll put the cover back on the differential, or the rear end, and then you're going to go ahead and fill it with the proper lube, which for this particular unit is 75-140. It's a very loose liquid. It has to be in order for it to run down and lubricate the bearings. So with that being said, that's pretty much it. I hope it was helpful to you, and you guys can use maybe some of what you heard. Thank you very much, and we'll talk with you again next time. Bye.